So in the last video, we talked about nomenclature, and we said that you're probably going to have to kind of get used to looking at IUPAC names, the actual systematic name that's encouraged by the IUPAC body. And that's typically how these compounds are going to be listed in a reference textbook. But that's not the only thing that we can look at. So what they've decided to do is throw in another wrench into the mix. And IUPAC made the determination saying, well, we know that a lot of people are not going to be comfortable with every IUPAC rule that's out there because there's tons of them. And IUPAC can sometimes be a problem. And if you don't follow the rules properly, you actually might end up with the wrong IUPAC name. You think that it's the correct one when it's not. So what they decided to do is simplify this mess a little bit, and they know that these different variations will cause a problem. So one person said, well, why not take a look at structure? Why not list things in order of structures? Well, they kind of shook their head on that as well, because there's different ways to represent structures as well. I can write in structures, 3 or 4 different formats for you. And if you're not comfortable with all the formats, then it's just going to confuse you as well. So they said, no, we're not going to actually list it in form of IUPAC name every single time. We're not really going to list it as far as structure goes every single time. We're not saying that we can't, because there are reference textbooks out there that will do that. But we need a better kind of surefire way to make sure that people are using the correct information at their disposal. So there's millions and millions of chemicals now. All right. So I'm going to put million plus. Millions of chemicals with millions of names and millions of structures. And what they've decided to do is to save any confusion. When you go and look these things up, you can double check yourself to make sure that you're looking and you're using the right proper name or the right proper structure. And you look for what we call a CAS number. That's pretty important. A CAS number. All right, so I'm going to clear the screen off, and we're going to talk more about CAS. What does CAS stand for? Well, CAS, the C stands for chemical. Go figure. The A stands for abstract. And the S stands for service. A chemical abstract service number. And all CAS numbers are unique. So, what does that mean? Let's say I've got a chemical. Here it is. I'm not going to draw the structure, but let's say there's 5 different ways to draw the structure. That can cause a problem from someone if they are using a reference textbook and they're trying to figure out which structure should I use and try to find the information that matches that. And let's say there's 10 different names that go along with the structure. Which one do I use? And when I do find the structure and when I do find the name in a textbook, how do I know if it really is the proper one that I'm looking for? Well, in all of these entries, there will be a CAS number. And that CAS number is going to be one unique number that represents any variation of structure and any variation of the name that particular compound can be used or can be drawn or can be named. On the reagent bottles in a laboratory, you're going to see a label. On that label is a couple of different pieces of information. And on that label, you will almost always see a CAS number listed. So if you're going to be using that chemical, you can look at the CAS number, and then you can use that CAS number into maybe an online resource, type it in, and that will immediately pull up the proper information that you need for any of those chemicals that you're using in a laboratory. It makes it much simpler. It makes it easier. You don't have to chain out or write out a huge, big, long name that might be 20 or 30 letters long. You don't need special software to draw structures into a software system and have it find out what you need. You simply just need a CAS number that you can type into a database, and it will immediately pull up the proper information that you need for that particular chemical. It's as easy as that. Now, where else can I find CAS numbers? Well, CAS numbers are going to be found on labels of reagents, liquids, solids, gases, whatever you decide to use in a laboratory. That's one of the ways that you can find a CAS number. The next one is that it's always going to be listed on an SDS form, and SDS stands again for Safety Data Sheets. We're going to talk more detail about these safety data sheets a little bit later on, but a safety data sheet does just that. It gives you safety information, and CAS numbers will be listed on those sheets. So again, you can confirm that you are reading information about the correct substance. Other ways that you can get CAS numbers is through online resources. So this would be NIST's website or a website called chemindustry.com. These are typically websites that are free for you to use, at least to get the basic information from. You can find stuff that you would find on Wikipedia. This would be chemical structures and chemical names and boiling points and melting points and densities. And you can find some safety information about these compounds as well through those websites. Wikipedia will also sometimes list the CAS numbers for you. We do not encourage you to use Wikipedia for any kind of particular special information. A lot of the physical properties, they are verified, so using Wikipedia for those sources or for that information is perfectly fine. And a lot of our physical and chemical properties are verified from different reference textbooks. So Wikipedia can be a very useful website for you to use. But I want you to keep in mind that Wikipedia is also open source, which means anyone at any time can submit information to extend this body of work. And that information might not be verified by the time you go to it and you look at it and you read about it. So these could be possible lies that someone just typed in, and until they double check and reference that data, it's going to kind of stay there and you will not know anything else about it. So that's the only thing that I will say about Wikipedia. Use it, but use it with some scrutiny. Because sometimes it's not going to be 100% correct. So since we've mentioned labels, I just want to take a few moments and maybe elaborate just a little bit more on this. It's going to come back a little bit later on, but you need to understand that all chemicals have labels, and it has to have very specific details on that label. This is really mandated by OSHA. They have a very large hand in figuring out what type of information should go on a label, the format of the label itself, How easy is the label to read? What can we leave off of the label that's not very important that someone can go to and maybe look up in a different reference textbook or literature source? But OSHA, which is basically the Occupational Safety and Health organization or association, will have a hand in the labeling requirements. They do, however, say that hazards, very important hazards, they need to be listed on the label. So if something is very major, like flammable, then that should be on the label in some form, in some fashion. So they tell us that the CAS number has to be involved. They also tell us that specific hazards have to be listed on that label in some form and fashion as well. All chemicals have hazards. All right. So this is something that we have talked about before. I don't want you to go with the assumption that everything is dangerous and going to poison and going to kill you, because that's just simply not the case. All chemicals have hazards. Even water has hazards. So if you look up the safety data sheet, those are the types of things that you're going to see. Not only that, but this is plural, right? It can have more than one hazard. So there could be flammability issues, there could be corrosiveness issues, there could be toxic issues, but we're going to put the major focus on the big ones, on the major ones. So we're going to call these the principal hazards, right? The principal hazards are going to be the ones that we want to focus on the most. There are other minor hazards, but that does not mean they are unimportant. So a minor hazard could cause skin irritation or an allergic reaction, or it could give you kidney damage if you expose yourself to it long term. Those things are something that they will not put on a label because it's not immediately necessary to know when you use it, but these are part of an umbrella of different types of hazards that might be involved with the chemical. They're just not going to place a focus on it for whatever reason is there. So your safety data sheet is going to list all of the hazards associated with the chemical, but the label itself will not list every single one of them. Okay, so SDS is the place to find all of them. The actual label is the one to look at for major hazards that are there. I also want to say that the SDS form, we keep talking about this, we keep bringing it up. We just now said all the hazards are listed, right? However, people make fun of the SDSs, and that's simply due to the fact that they have to list every single thing that this chemical can do. Next time you're watching TV and you're going through the commercials, if you see a commercial for a pharmaceutical drug, something for you to go to your doctor and get prescribed, take a look and a listen at all of the side effects that they tell you about that drug throughout the commercial. It's going to probably take up the majority of the time of the commercial at the very end. Or if you're flipping through a magazine and you find a magazine article or an advertisement about a new pharmaceutical drug, read the fine print. You're going to see tons and tons of side effects that can happen to you if you take that medication. The same thing happens with SDS. People make fun of them because sometimes the hazards, there's so many of them, and sometimes they don't even make sense, right? Again, water is dangerous in large quantities. Give me a break. We drink water every day. We need to drink water every day, but the SDS is going to have a hazard that's associated with water. And the reason, we'll talk about those reasons a little bit later, but it's more legal reason than anything else. So OSHA has a hand in this. They began to think about a way that they could maybe make this universal. So after OSHA put their stamp on it, after the United States started requiring certain pieces of information on labels, then we get another kind of organization that comes along, And these people are going to be called a globally harmonized system of classifying and labeling chemicals. We shorthand this to GHS. So GHS is the globally harmonized system of classifying and labeling chemicals. And it's been adopted by the United States, and it's been adopted by OSHA. They are okay with this. Both organizations are completely fine. And the reason that this came along is because in the United States, if we had a chemical, then we had certain rules that needed to be on that label, right? And if one company in the United States wanted to transport or sell that chemical in another country, then all of a sudden that chemical and that label had to abide by the rules of that particular country that it's going to or being transported in. So these were all kinds of issues that were brought up. You know, if China and Japan and the United States all wanted to get together and transport and make a chemical because that pharmaceutical company maybe was in all three locations, how on earth can we put a systematic process to the madness with all of the different countries, with all of the different rules that we might have to follow? That's where the term globally comes into play, because what's happened is that there's a large number of companies now that sit at this table, and they basically go over the requirements of things like labels on chemicals, and all of these people make up, literally, the rules and regulations that they would like seen. And as long as all of the countries follow that globally harmonized system, then that means that they do not have to change anything if they do want to sell or transport that chemical in other countries across the world. So it made a much better system as far as communicating and transferring and transporting chemicals from one laboratory to the next if they are in different countries throughout the world. Okay? So the United States kind of went a little bit further, and they are part of the globally harmonized system now. And OSHA and the United States has basically adopted that plan. Labeling requirements are also now part of HAZCOM. So we've talked about HAZCOM before in a previous lecture module. And HAZCOM, what we're referring to here, is 29 CFR 1910 1200. Okay, 2012, OSHA revised it. OSHA revised the HAZCOM. And the reason that they did this is because they wanted it to match the GHS system a little bit better. So we kind of had a process in place. We had some requirements as far as labeling goes in place that was already included in the CFR that we've talked about before, and this was part of HAZCOM, Hazard Communication. So when the globally harmonized system came out, then we've made the decision to go ahead and not only join that system, but also adopt those rules now permanently in the HAZCOM system itself, and that happened in 2012. So now we can say that labels are what we would call standardized. They have made a rule, and they said this is what you've got to have, and this is the format that it's got to be in, and we need to go through the checklist to make sure that all of that information is on the label before you sell, manufacture, or transport that chemical. So what are the things that are required on chemical labels now? Okay, number one is going to be a product identifier. A product identifier is basically a name, right? So we have to know what's in that jar, and that is typically a name that is printed on the jar. Now, it says product identifier. It doesn't necessarily say it has to be the IUPAC name. It doesn't say that it has to be the common name. It just says an identifier. You have to know what's in that bottle in some form or fashion. There's got to be a name that's present. It's not going to require which one's which. It's going to let the company make that decision, but it has to be an identifier so we know what's in it. Next one is a pictogram. A pictogram is basically a symbol. There's 9 of these, and they are known as the HASCOM standard. This was kind of already in place before GHS came along. GHS probably changed a little bit of it, nothing major though, and maybe the images that we use, but there are 9 symbols that we would find on a chemical label or possible on a chemical label. The next one is a signal word. The signal word is typically either the word danger or the word warning. We'll talk about the differences in just a second, but those are going to be the signal words to you as a user. So if you see one or the other, you know to pay special attention to that chemical because it can do something. Next is what we would call a hazard statement. It's basically a synopsis of what we would call the main hazard. For instance, reacts with water. If there's something pretty important or pretty drastic that we need to know about the chemical, then that statement is typically printed on the label somewhere. And it's typically all caps. It's typically all bold. It's not a requirement to be that way, but that's typically how we would see it. And finally is the supplier information. So where did I get this chemical? Who made it? Who shipped it? What kind of lot number? What kind of date was it bottled up? Those are the types of things that I would find in the supplier information. That way, if there's a problem with that compound, I know who to contact and I can tell them about the problem that I'm experiencing. And if other people are seeing the same problem, or if they still have that lot number in place, they can recall that chemical, bring it back into the company, and not sell it. Just like a consumer product recall. The same type of thing can happen with chemicals as well. Now, they're also going to make a statement, and it says, additional information is welcomed. That basically means you can put whatever you want to on the bottle after that. Whatever you have room for on the label, you can do whatever you want to do. But these are kind of the 5 major requirements that needs to be on every single label on a chemical. It's got to be the name of the substance, the pictograms if needed on some of the hazards, signal words of danger or warning to let someone know they've got to be careful using it. Some type of hazard statement, if applicable, should be on the label. And then finally, the supplier information. Where did it come from? Who made it? Who bottled it? Who shipped it? Those are the types of things that we would see in the supplier info. So I'm going to stop the video here. In the next video, we're going to come back and we're going to review a little bit of terminology. So some of the words that might be stamped onto these labels. We just want to make sure we're all on the same playing field. We want to make sure we understand some of the definitions that might be out there that we would see on a label itself. And that's what we'll do in the next video.